Hello, and welcome to this beginner's guide to inheritance and polymorphism in C# for Unity. If you're new to programming or just starting with Unity, you're in the right place. This tutorial will provide a foundational understanding of these crucial object-oriented programming concepts, specifically tailored for game development within the Unity environment. In this video, we'll break down object-oriented programming, or OOP, and explore two of its most powerful and frequently used concepts, inheritance and polymorphism. These principles are essential for writing clean, modular, and scalable code in C#. OOP is a widely recognized and popular paradigm in software development, known for its efficiency and organization. The primary goal of this video is to help you not only understand what these terms mean, but also to equip you with the practical knowledge to apply them effectively, enabling you to write better, more organized, and maintainable code in your Unity projects. Let's start with inheritance, a core concept in OOP. Think of it like a family tree, a concept we are all familiar with. Just as you inherit certain traits, characteristics, or even predispositions from your parents, in programming, a class can inherit properties and methods from another class. This allows for code reuse and establishes a clear hierarchical relationship between classes. To demonstrate this practically, let's create a new Unity project and a basic C# script within Visual Studio. We'll begin by establishing a foundational class, which we will call enemy. This enemy class will serve as the blueprint for all our future enemy types. This enemy class will encapsulate common properties that all enemies share, such as health to track their vitality and speed to define their movement rate. It will also include fundamental methods like take damage to process incoming attacks and die to handle their defeat. Pay close attention to the virtual keyword used in these methods. We'll revisit its significance later when we discuss polymorphism. Now, building upon our enemy base class, let's create two more specific classes, Goblin and Dragon. These new classes will not be standalone entities. Instead, they will inherit directly from our enemy class, meaning they will automatically gain all the properties and methods defined in enemy. Observe the syntax carefully, the ::, followed by enemy in the class declaration. This is the explicit way we inform C# that these new classes, Goblin and Dragon, are derived from or inherit from the enemy class. Consequently, they automatically acquire all the members of the enemy class, including health, speed, take damage, and die, without us having to rewrite that code. In Unity, we can now create two game objects, assign them the Goblin and Dragon scripts respectively, and immediately observe how they already possess the health and speed variables in the inspector panel. This clearly illustrates how inheritance saves us from writing the same code multiple times, significantly reducing redundancy and making our codebase much easier to manage and extend in the long run. Helpful tip: inheritance is an incredibly powerful tool for creating a clear hierarchy of related classes. This is particularly useful for categorizing different types of game entities, such as various enemies, different kinds of items, or a range of vehicles. If you find yourself repeating similar code across multiple classes, it's a strong indicator that you should consider implementing inheritance to streamline your development process. Next up, let's delve into polymorphism. The word polymorphism originates from Greek and literally means many forms. In the context of object-oriented programming, it signifies that an object can take on many forms, or, more precisely, that objects of different classes can be treated as objects of a common type, allowing for varied behaviors through a unified interface. Do you recall the virtual keyword we encountered earlier in the enemy class? That keyword is crucial for polymorphism. It acts as a signal, allowing derived classes to override the method and provide their own specific implementation. Let's now add an attack method to our enemy.cs script and explicitly mark it as virtual. Now, in the Goblin and Dragon classes, we will leverage the override keyword. This keyword explicitly tells C# that we are providing a specialized implementation for the attack method that was declared as virtual in the base enemy class. This allows each derived class to define its unique attack behavior, such as a goblin attacking with a club or a dragon breathing fire. This is polymorphism in action, a fundamental concept that allows for flexible and extensible code. Even though both Goblin and Dragon inherit from enemy, their attack methods behave distinctly based on their specific implementations. This means a single type of reference, such as an enemy object, can effectively refer to objects of different derived types, like a goblin or a dragon, and invoke their unique behaviors through a common method call. Let's now transition to Unity to see how this powerful concept works in a practical game development scenario. We'll create a simple spawner script that will manage a collection of enemy objects and then instruct each of them to perform their attack action. Within Visual Studio, we'll define the enemy spawner.cs script. This script will contain a list of enemy objects. In its start method, we'll iterate through this list using a for each loop, calling the attack method on each enemy instance. This setup will demonstrate how polymorphism allows us to treat different enemy types uniformly while still executing their unique attack behaviors. Now, back in the Unity editor, create a new game object and name it Enemy Spawner. Attach our newly created Enemy Spawner script to this game object. Then, drag our existing Goblin and Dragon game objects into the enemies list exposed in the Inspector panel of the Enemy Spawner. When the game starts, the attack method will be called on each enemy in the list, showcasing their distinct actions. Observe the Unity console output when the game runs. You'll see messages like Goblin attacks with a club and Dragon breathes fire. This clearly demonstrates that even though we are calling the same attack method on a list of generic enemy objects, each derived class executes its own unique attack behavior. This dynamic behavior, where a single method call results in different actions based on the object's actual type, is the essence of polymorphism. Helpful tip: polymorphism is an incredibly versatile concept that proves invaluable in various game development scenarios. It is particularly helpful when designing complex systems such as artificial intelligence behaviors, intricate weapon systems, or many other common game mechanics, where different entities need to perform similar actions in their own unique ways. These concepts, inheritance and polymorphism, are not just theoretical constructs. They are fundamental pillars of object-oriented programming. Mastering them can significantly improve the structure, flexibility, and maintainability of your Unity projects. I strongly encourage you to practice and experiment with these concepts in your own projects. The more you apply them, the quicker you'll be writing cleaner, more powerful, and more scalable code. Thank you for watching this tutorial on inheritance and polymorphism in C# for Unity. We sincerely hope you found it helpful and that it aids you significantly in your journey to master C# and Unity development. Keep exploring, keep coding, and never stop learning.